Is it visible to you, the presentation?
Yes, sir.
Okay. So now scalar product, we call it as a normally dot product of the vectors. Okay. So the definition, whenever you see that scalar or dot product is denoted by the two vectors, between them dot will be written. Cross product is nothing but both between them, the cross symbol will be written here in this way. So scalar and dot product differences are, scalar means dot product will give you the scalar. That's why we call it as a real number. We call it as a, one number will be you are going to get. When you are finding the dot product of the two vectors, dot product, in the product you are going to have the two types of the product. One is dot product, another one is cross product. So dot product of the vectors will give you the one real numbers. That's why that real number is called scalar, and we call it as a, that's why we call it as a scalar product. So it is defined as two vectors a and b is taken, and that the dot product will be defined as a magnitude of the a bar and magnitude of the b bar into cos theta, where theta is the angle between the two vectors, and it should be lies between 0 and 180 degrees. So in case if that a bar is 0 vector and b bar is a 0 vector, 0 vector is different here in this case. So a is a 0 vector and b is a 0 vector. Their dot product is also 0 because both the vectors are representing the same vector. The angle between them is 0. Cos 0 value is normally 1, and and a vector magnitude is 0, b vector magnitude is 0. So 0 into 0 into 1 value is 0 we are going to get. So the main products of the dot product whenever you are taking into consider. So a bar dot bar compulsory, the dot product of the two vectors is a real number, you need to remember here in this case. So it is a real number, we call it as a scalar. Okay. So always the dot product, how do we find out the dot product? We will learn it. And if the dot product of the two vectors is 0, means the two vectors are perpendicular to each other. Two vectors are perpendicular to each other. So if the two vectors are perpendicular to each other, the angle between them is 90 degrees. When it is 90 degrees, cos 90 degrees value will be equals to 0. So therefore, the two vectors dot product will become 0. So if the two vectors are perpendicular to each other, then their dot product is equals to 0. Okay. So this is the one property of the dot product of the two vectors. If the both the vectors are same vectors, means coincide, if the angle between them is 0 degrees, then the dot product will be is equals to magnitude of a bar plus into magnitude of b bar, because cos 0 degrees is value is equals to 1. So that is nothing but if the both are having a same direction in the same way, either they may be a parallel also. So that a bar dot b bar is represents that they are having the coincidental line, just like coincidental vectors there. So both the vectors are same vectors. So a bar dot b bar is equals to, in that case, same vectors whenever you are taking, magnitude of a bar square we are going to get. If they are in an opposite direction, means one vector is, means the angle, means the vectors whenever you are taking into consider, it is represented, one vector is one side, another vector is its opposite side, where you are having the angle between them is 180 degrees. When cos 180 degrees is equals to -1, then the a bar dot b bar is equals to magnitude of a bar minus of magnitude of a bar magnitude of b bar, we are going to get it. So this is a one point. So a bar dot b bar is equals to, in that situation, both are having same vector. So magnitude minus, we are going to get minus of magnitude of a bar whole square, we are going to get it. So the fifth property is a bar dot b bar is equals to magnitude of a bar into magnitude of b bar into cos theta. So then cos theta can be find out, means that angle between the two vectors can be find out by using the dot product. And how do we find out the dot product of the two vectors? We learn it. Okay. So a bar dot b bar is equals to the magnitude of A bar means both are will satisfy the commutative property. So these are the main properties of the dot product. Dot product is a real number. If the dot product is equal to 0, perpendicular. Okay, if they are parallel now normally, then we are going to get it as a, if they are parallel means one side same coincidental lines, if you are having, the magnitude of A bar square we will get. If one is one side and other one is other side, you are going to have, then we are going to have the magnitude of A bar square. And the angle between the two vectors can be found out by using the formula cos theta is equals to A bar dot B bar by magnitude of A bar magnitude of B bar. This is a scale, we call it as a scalar product. The next thing is scalar product. And how do we find out that scalar product? Let us see here. Two three-dimensional space, whenever you are taking, the unit vectors along the x-axis, y-axis, z-axis coordinate axis will be represented as a I, J, K. These are the unit vectors. What is meant by unit vector? Unit vectors is nothing but whose magnitude is equals to 1. That is, magnitude of the two vectors is equals to 1 means we call them as a unit vectors. So here I dot I is equals to 1, J dot J is equals to 1, K dot K vectors. And cap, why it is written here, cap represents that it's a unit vector. When it is given to you cap, it's a represents that. So these three are mutually perpendicular unit vectors. So when they are mutually perpendicular, their dot products will be equals to the 0. So their dot products will be equals to the, means I dot j is equals to 0, j dot k is equals to 0, k dot I is equals to 0. So the dot product of these vectors will be is equals to 0. We are going to get it. Okay, so main properties, whenever you see here, properties of this scalar vector, scalar product, whenever you see that, two vectors we are taking into consider, A and B. So the dot product of these two vectors, A vector is the definition, as per the definition, A bar dot B bar is nothing but magnitude of A bar into magnitude of B bar into cos theta. Magnitude of A bar into magnitude of B bar into cos theta. Okay. So distributive property of the dot product over the vector addition. Distributive property of the dot product over the vector addition will satisfy, that is A bar dot B bar plus C bar is equals to A bar dot B bar plus A bar dot C bar. So dot product will satisfy. Multiplication of the dot product of the vector with a scalar. So when you multiply the dot product by the scalar, in any way you can multiply. That scalar multiplication can be done to the single vector, first vector, or it can be done to the second vector. So dot product of the two vectors. How do we find out? A vector is given to you like this: A1 I, A2 J, and A3 K. B vector is given to you B1 I, B2 J, and B3 K. So when you are multiplying normally, I dot I is equals to 1 and I dot J, I dot K is equals to 0. So any unit vector with itself is equals to 1, with other it is equals to 0. So when I dot J is I dot K is equals to 0, J dot I and J dot K is equals to 0 if you are substituting, and we are going to get the final product as a A1 B1, A2 B2, A3 C3. So here the points are unit vectors, na? The coordinates of that particular points will, yes, these values see here. I dot J, J K dot I, or I dot K. Dot product satisfies the commutative property, so that's why I dot K or K dot I both are equal. All are zeros, and J dot J, I dot I, K dot K is equals to 1. These values, if you are substituting there, the final, the dot product of the two vectors, we are going to get it as a A1 B1 plus A2 B2, A3 B3, sorry, A1 B1, A2 B2, and A3 B3 will be left out. Okay. So this is a way to find out the dot product of the two vectors. When the two vectors are given, their dot product can be found out in this way. So their coefficients of these unit vectors, whatever it is given to you in that, should be taken into consider. So properties of the scalar vector, whenever you take into consider here, what are the properties? Means the angle between the two vectors is theta. Usually it is denoted by. So a vector is making an angle of theta with the L. So when you draw a perpendicular line from A to B over AB, so OB is represented by P bar, then it's O to B is a line, the vector. In this triangle, cos theta is equals to OB by OA, we are going to get. Cos theta is adjacent by hypo. So from this, P vector is equals to A vector into cos theta, we are going to get it. P vector into A vector into cos theta. That means any vector, if it is making an angle of theta with any other vector, so that vector, if you need to find out, the magnitude of P vector is equals to magnitude of A vector into cos theta. Magnitude of P vector is equals to magnitude of A vector into cos theta. So if in case the theta value is equals to 0, then the P vector and A vector will coincide. Both are same vectors, we are going to get it. Okay. And in case if it is less than 90 degrees, then the direction of the P vector is same as the direction of the in the direction of the line L. If that A vector is means the angle between the two vectors is equals to 90 degrees, then P vector will be equals to 0 vector, null vector. We call it as a null vector. And if it is more than 90 degrees and less than 180 degrees, then the direction of the P vector is opposite to the direction of the line L. Line L ka opposite direction we are going to have. If it is completely opposite, and if the angle is equals to 180 degrees, and P vector and A vector P vector is equals to minus of A vector, we are going to already in the dot product concept we have learned all these things. If it is more than 180 degrees, if the angle between them is more than 180 degrees and less than 270 degrees, P vector is opposite to the direction of the L, line L. And if it is equals to 270 degrees, exactly, the angle is equals to 270 degrees, then cos 270 degrees value is equals to 0, then the P vector will be equals to null vector. The vector is null vector we are going to get. So if the 0 degrees, it is same vector. If it is 180 degrees, minus of that vector. If it is 90 degrees, 0 vector. If it is 270 degrees, it is 0 vector. More than 270, less than 360 means in the direction of the. So whenever you consider like this, what you can observe from all these things, whenever we are drawing, P is a unit vector along the line L. So P vector is equals to A vector into P cap. P cap is the unit vector along the line, means if P vector can be taken as A vector into P cap. So we call the projection of the A along the another vector B. We call it as a projection. Projection of the vector A vector is there, na? That A vector projection along the another vector B is given as A bar dot B cap, means any vector if it is given to you and its vector projection along the another vector, means B vector, if you want to find out that another vector unit vector, you need to find out. So we need to find out unit vector. B cap is a unit vector along the B bar. B cap is nothing but B vector by magnitude of B. So the projection will be given to you A bar dot B bar by magnitude of B. Magnitude of B bar means the dot product of the two vectors to be taken into consider by, means on which line we are projecting, that line magnitude should be taken into consider. Okay. So given vector is, if A is a vector, A1i, A2j, A3k means A1 is called projection of this vector on the x-axis. Projection of this vector on the x-axis means x-axis, on the x-axis we are taking. So magnitude of x-axis, whenever you take it as a unit vector, we are going to get it. So it's a coefficient directly we are going to get A1. A2 represents the projection of the A vector on the y-axis, and A3 represents the projection of the A vector on the z-axis. So the direction cosines of this vector, normally direction cosines of this vector are given to you. Cos alpha is equals to A vector by magnitude of A vector, A1 by magnitude of A vector, A2 by magnitude of A vector is cos beta. Cos gamma is nothing but A3 by magnitude of A vector. So, okay. So this point you try to remember. If A vector is a unit vector, then the vector is itself can be written as, because A vector unit vector means A1 is cos alpha, A2 is cos beta, A3 is cos gamma we are going to get. So that's why the vector can be written as cos alpha into I vector, cos beta into J vector, cos gamma into K vector. Okay, so this is the dot product of the two vectors. Okay, the next thing is cross product. When you are taking the cross product of the two vectors, dot product is vector itself. Dot product is real number, but the cross product of the two vectors is also one more vector. It is a vector in that. So here you need to take the right-handed system. Means the right-handed system means you need to hold these three fingers like this, which are mutually perpendicular lines, x, y, and z axis. How do you take in that way? So one vector is represents that, which is z axis here. X axis is one direction, and this direction y axis. We call it as a right-handed coordinate system. So you hold your hand and you take the hand in this direction. Fingers are all in one direction. All the fingers in one direction means one finger is one direction and another finger is direction, and another finger like this. You need to hold that. When you are holding like this, and one finger will show it to you the one axis, another finger will show to the other axis, and other finger will show the three different axes. Let us consider the given that here p vector is not a null vector and q vector is also not. Theta is the angle between these two vectors, and the theta is between 0 and 180 degrees. If the theta is, then the cross product of these two vectors is defined as magnitude of, this is the definition of the cross product, magnitude of p bar, magnitude of q bar into sine theta into n cap, where this n cap is mutually perpendicular unit vector to the given two vectors. That means usually you consider that these two vectors are on the plane, and another vector which is perpendicular to both the vectors. That two unit vector should be taken in. So n cap is the vector which is perpendicular to both the given vectors. That means both the vectors are on the same plane, and this vector is on the air. Just like you consider that where you are sitting on the table, these two vectors are on the table. Okay, the angle between them is something, but the third vector n is which is perpendicular to both the vectors in the perpendicular to both the vectors, and it is a unit vector. So if in case here p vector is a 0 vector, then the magnitude is 0, q vector is a 0 vector, then the magnitude is 0. Thus, if either p or q is 0 vector, so in that cases we are going to get the cross product as a 0 vector. So the main properties whenever you take into consider, the cross product of the two vectors is also a vector. Cross product of the two vectors is also a vector, and it is defined as, the cross product is defined as magnitude of the first vector into magnitude of second vector, sine of the angle between these two into the unit vector which is perpendicular to the two given vectors. Okay, so that is the thing you need to remember, the cross product of the two vectors. The vector n cap is a one vector which is per vector hai na, that is, so that's why the final product we are going to get as a vector. Okay, so dot product is scalar, cross product is vector. That too, that vector we are going to get it, which is perpendicular to both the given vectors. So property 2 says that if these both the cross product is zero vector, then both the given vectors are parallel to each other. Let P and Q are two non-zero vectors. The angle between them is 0. Then angle 0 is nothing but sine 0 degrees value is 0. So finally we are going to get a 0 vector. That means the two vectors are, if the two vectors are non-zero vectors, their cross product can be a 0 vector if the angle between them, in case if it is 0. So what you can observe, that means two same vectors cross product is always a 0 because the angle between the two same vectors is 0. Angle between the two vectors is, two same vectors is 0 always. If the two vectors are in opposite direction, one is in one direction and another one is the other direction, there also their cross product is equals to 0 because the angle between them is considered 180 degrees. Sine 180 degrees will be equals to 0. This is the main thing you need to observe here. Okay, so when the cross product of the two vectors is 0, either they are means parallel to each other, they are in same direction, or they may be in opposite direction also. So let us consider the x-axis, y-axis and z-axis. The cross product of the unit vector along the x-axis, y-axis, z-axis, same axis whenever you take, we are going to get the 0. You remember that the dot product of the unit vectors along the coordinate axis is equals to 1. I dot I is equals to 1. J dot J is equals to 1. K dot K is equals to 1. Any vector, unit vector with the other perpendicular vector whenever you are taking, it is equals to 0. That is nothing but I dot J or I dot K or K dot I is equals to 0. But in case of the cross product, if you take into consider, I cross I value is 0 vector. Vector here, their number. I dot J is 0 scalar. Here I dot I unit vector is equals to null vector. J dot J is a null vector. K dot K is null vector. If P and Q are two perpendicular vectors, that means the angle between them is 90 degrees. Then the magnitude of P bar and cross P bar is equals to magnitude of P bar, magnitude of Q bar. Why? Because sine 90 degrees value is equals to 1. Sine 90 degrees value is equals to 1. And here magnitude of any unit vector is equals to 1. Sine 90 degrees 1 and unit vector magnitude is equals to 1. So that's why the magnitude of the cross product, of the two vectors is equals to the magnitude of the product of the magnitudes of the two vectors individually. Okay, so this one thing you need to
Yes, sir.
observe. What?
Nothing, sir.
Okay, so sine 90 is 1 and unit vector magnitude is equals to 1. So that's why we are going to get this as a cross product. Cross product whenever you take, when you take the cross product, magnitude of the cross product of the two vectors. When you take the magnitude of the cross product of the two vectors, we are going to get like this. Okay. So angle between the theta is between the two vectors is given to you. If the angle is given to you, and p and q vectors are given, then sine theta, if you want to find out, then cross product divided by magnitude of p, magnitude of p. Cross product is not a commutative, because commutative property does not satisfy. Why? Because if it is commutative property satisfies normally, p cross q will not be equals to q cross p. P cross Q is nothing but what do you get here? PQ and sine theta and a unit vector along that. And Q cross P is nothing but downwards. And so direction is going to change here. The unit vector direction, the unit vector which is perpendicular to the both the given vectors, direction is going to change. Q P means. So n cap in dash means in downwards direction wherever you are taking, they are not equal here. So that's why we are not going to get the minus we are going to get it. So that's why these will not satisfy the commutative property. Commutative property will not be satisfied. Cross product is not a commutative. So for mutually perpendicular vectors, whenever you take I and j, I cross j is equals to the vector which is perpendicular to both the given vectors. Can anyone tell what is the vector which is perpendicular to both the given vectors? I is a one vector along the x-axis, j is the vector along the y-axis, k is the vector along the z-axis. So the cross product of I and j means what do we get? K we are going to get. Yes. The cross product of the I and j is equals to k. So cross product is not a commutative. Cross product of the j and I minus k. So in a cyclic order, you need to take into consider j into k is again I we are going to get. J into k is I into j is minus k. So j into k is I. K into j is minus I. So the same way k into I is j and j I into k is minus j. P vector and q vector is taken here. And from the q to p, the point is, if p and q represent the adjacent sides of the triangle, if that represents the adjacent sides of the triangle, then the area of the triangle is equals to half of the magnitude of the cross product of these two vectors. P and Q represent the adjacent sides of the triangle. Then the area of the triangle is half into base into height. So that means here half into the base is P vector and height is OP is the base and height is QR. So OP is nothing but here. Normally in a right angle triangle, sin theta is equals to QR by OQ. QR is equals to OQ into sin theta. In the triangle, OQR should be taken into consider. Okay. So from this, we are going to get it that result as a OP, OQ, sin theta. OP, OQ, sin theta is nothing but and magnitude of P. OP is nothing but magnitude of P vector. OQ is nothing but magnitude of Q vector into sin theta. So that's why at magnitude of P vector, magnitude of Q vector into sin theta we are getting half into magnitude of P. And here this will be represented as a magnitude of P cross Q is represented as a magnitude of P into magnitude of Q into sin theta. You may get doubt here that where is n cap? Because we are taking magnitude, as we are taking magnitude, the magnitude of n cap is equals to 1. So that's why it will be disappear. So area of the triangle is like that. So the cross product of the two vectors we can find out here. Two vectors are given. This is product means parallelogram. Adjacent sides of the parallelogram if it is given to you. P and Q are the adjacent sides of the parallelogram. then the area of the parallelogram is magnitude of P cross Q. Magnitude of P. Just as we did in case of the triangle, in the same way, this can also be evaluated. So do remember that if the adjacent sides is given to you for the triangle, their cross product, if you are finding and divided by 2, we are going to get the area. Distributive property of the cross product. For any 3 vectors, distributive property will satisfy. For any 2 vectors with the scalar product, whenever you are taking, it will satisfy. Okay. And A is the one vector, B is the one vector, and theta is the angle between them. How do we evaluate the cross product of the 2 vectors? To find out the cross product of the 2 vectors, we have to use the A1 into I. So very lengthy process if you are using the horizontal method, whatever you are using here. So to evaluate this one, matrices concept will be used here. You see here A1 B1 into I cross I. A1 B2 into I cross J. A1 B3 into I cross K. So in this all, I cross I, J cross J, K cross K values are equals to 0. But the cross product of the any vector, unit vector, along with that unit vector is equals to 0. But I cross J value is K. I cross K value is minus J. I cross K. So these points you need to keep in your mind, and all these values you need to substitute in the given. So values whenever you are substituting like this, I cross K value, J cross I value, J cross J value 0, J cross K value I, K cross I value J, and K cross J value minus I, K cross K value is 0. These values are substituted. Then we are going to get the final result like this: A2B3 minus A3B2I minus of A1B3 minus A3B1 into J plus A1B2 minus A2B1 into K. This, to remember, it is a difficult task to you. That's why determinant of the matrix obtained, this you need to remember here. Determinant of the matrix obtained by I, J, K as a first row, A1, A2, A3 as a second row, B1, B2, B3 as a third row. You find out the determinant of the matrix 3 by 3 matrix. We are going to get the same result whatever it is given to you here. So this is the way to find out the cross product of the 2 vectors. Okay.
Yes, sir.